Hey y'all, today is April 6th and we are doing a little mini lesson on scale drawings, 8-1 that we did today in class. So grab a piece of paper, a calculator, and a pencil and let's get started. So let's look at number 1 right here. It says Chris made a model of a lighthouse using a scale of 4 inches equals 50 feet. If the lighthouse is 120 feet tall, how tall is his model? Okay, so what I like to do is I like to remind myself that my scale is my model to actual, or the fake thing to the real life thing, right? Okay, I also like to come in here and make note of my units. So I know the model is being measured in inches and the actual lighthouse is measured in feet, right? So now I'm ready to use the ratio that's given to me, 4 inches equals 50 feet. So 4 inches is my model, 50 feet is the actual, and I'm going to use that in a proportion. So I'm setting it up to setting it equal to another fraction. Now the only other measurement I have is I'm told that the actual lighthouse is 120 feet tall. So where do I put that 120? Well, because it's feet, I want to put it on the bottom. So 120, and we're trying to figure out how tall the model is. So how many inches tall is the model? So now that I have this set up right here, this proportion set up, I can cross multiply to find the value of x. So to cross multiply, we're going to multiply 50 times x together, and that's just 50x. And I set that equal to 4 times 120, which is 480. Now to get that x by itself, I'm going to divide by 50 on both sides. My 50s cancel out. X is by itself. And 480 divided by 50, if you put that into your calculator, you're going to get 9.6. 9.6 what? 9.6 inches. So that's how tall Chris's model of this lighthouse is, 9.6 inches tall. Okay, let's move on to number 2. The scale on a map reads 1/2 inch equals 85 miles. If the distance between two cities on a map is 3 3/4 inches, find the actual distance between the cities. Okay, so remember, we're setting up our ratio. I like to do model to actual, or the fake thing to the real life thing. Okay, and we know that the fake thing is our map, right? And it's measured in inches. We measure our distance in inches there, but in real life, we measure our distance in miles. Okay, now I was given this ratio here. 1/2 inch equals 85 miles. So 1/2 inch, how can I represent 1/2 not as a fraction? Because I don't want to have complex fractions here. Well, 1/2 is the same thing as 0.5. So I'm going to use that decimal, 0.5. So 0.5 inches is equivalent to 85 miles, right? So that's my first fraction, and I'm going to set that equal to another fraction. Now, the only other measurement I'm given is 3 3/4 inches. So I know that that needs to go on the top right here because that's where my inches go. But how could I write it so it's not a mixed number or even a fraction? Well, remember 3/4. 3/4 is 0.75. So 3 3/4 would be 3.75, right? So 3.75 inches, and I want to know how many miles that would be, like the real life distance. How many miles would that be? Well, the way I solve this proportion is I cross multiply. So I'm first going to multiply 0.5 and x together, which is just 0.5x, and I set that equal to 85 times 3.75. And if you put that into your calculator, you get 318.75. Now, how do I get that x by itself? Well, I divide by 0.5 on both sides. And when I do that, my 0.5s cancel out. X is by itself. And 318.75 divided by 0.5, when I put that into my calculator, I get 637.5. But what is my unit? Remember, since that was on the bottom, it's miles. So 637.5 miles is the distance between those two cities. Okay, let's move on to number 3. Another map problem here. Oak Grove and Salem are 87 miles from each other. How far apart would the cities be on a map that has a scale of 5 inches equals 29 miles? Okay, so I like to set up my ratio as model to actual, or the map, the fake thing, to the real life thing, actual distance in miles. Okay, so we know our map has a unit of inches, and in real life we use the unit miles. Okay, we are told that on the map the scale is 5 inches equals 29 miles. So we're going to use that ratio. So 5 goes on top, 29 on the bottom, and I'm going to set that equal to another fraction so that I can solve a proportion. Now the only other distance I'm given is 87 miles right here. So where does that go? Does it go on the top or bottom of my second fraction? Well, I want to keep my units consistent, so miles goes on the bottom, so I put it down here. And I'm trying to figure out how far apart those cities are on a map. So now I'm ready to cross multiply. 29 times x is simply 29x. And then I multiply 5 times 87. And if I put that into my calculator, I get 435. Now to get that x by itself, I'm going to divide by 29 on both sides. My 29's cancel out. X is by itself. 435 divided by 29, if I put that into my calculator, I get 15. 15 what? 15 inches. Remember, I have to include my units. Okay, let's look at number 4. What is the actual length of the living space if the length in the scale drawing is 16.8 centimeters? Okay, so we've got this image here that we're looking at, and in this image it tells me my scale right down here. So I needed to notice that. My scale is 2 centimeters equals 2.5 meters. Okay, so 2 centimeters, I'm going to set it up like this, equals 2.5 meters. That's the ratio that I'm working with, right? Now, that ratio is a fraction. I just included the units there, so I'm going to just set that equal to another fraction. And I want to know, what is the actual length of the living space if the length on the scale drawing is 16.8 centimeters? Notice 16.8 centimeters. So where do I put something that has centimeters? Well, the way I set it up is to put centimeters on top. So I'm going to put 16.8 right here, and we're trying to figure out the number of meters the length of that living space is. So I put my x on the bottom. So now I'm ready to cross multiply. So 2 times x is simply 2x, and set that equal to 2.5 times 16.8. If you put that into your calculator, you're going to get 42. Now to get that x by itself, divide by 2 on both sides. So x equals 42 divided by 2 is 21. 21 what? 21 meters. We have to include that unit. So the actual length of the living room is 21 meters. Okay, let's look at number 5. Jada made a model of the Space Needle in Seattle for a science project. She used a scale of 2 inches equals 55 feet. If the actual height of the Space Needle is 605 feet, how tall was her project? So this one is kind of like that very first one we did. So we are given this information here. 2 inches equals 55 feet. So I'm going to use that to make a ratio. So 2 inches, 55 feet. Okay, and this right here is telling me that I'm going to put inches on top and feet on the bottom, because I'm going to set this equal to another fraction, and I have to have my units consistent. So what other piece of information can we get from this word problem? Well, we know that the actual height of the Space Needle is 605 feet, right? Feet goes on the bottom, so I put 605 down here. And I'm trying to figure out how tall in inches her project is. So now I'm ready to cross multiply. So first, 55 times x is 55x, and we set that equal to 2 times 605 and that is going to be 1,210. So now to get that x by itself, divide by 55 on both sides. So my 55s cancel out. X is by itself 1,210 divided by 55. If you put that into your calculator, you get 22. 22 what? 22 inches. Don't forget to include those units. Okay, last one right here. This time we're going to find area. And I want you to make a little note that area equals length times width. Area is always length times width. So, what is the area in square yards of the deck represented by the scale drawing? Now, we're also told that our scale, oops, I'm crossing it out, I meant to highlight it, is 1 centimeter equals 2 yards, right? So, let's start with the length. And by length, I'm talking about this right here, okay? So, let me just make that a capital L. How about that? So, I want to know what 16 centimeters would be in yards, right? So, for length, we're starting with our ratio of 1 centimeter equals 2 yards. And I'm going to set that equal to another fraction. Okay, well, the only other measurement I have for length is 16 centimeters. Because it's centimeters, it needs to go on the top. So 16 goes on the top, and I'm trying to figure out the number of yards that are on the bottom. So now I'm ready to cross multiply. So 1 times x is simply 1x, but I can just write that as x. And 2 times 16 is 32. So x equals 32. 32 what? 32 yards. Now that's not my answer, right? That's just the length. So I'm just going to make that, kind of highlight it in gray for us, because now we have to find the width. Because remember, area is length times width. So we start with our same ratio for our scale. We have 1 centimeter is equivalent to 2 yards, or 1 centimeter represents 2 yards. Okay? Now our width is this measurement here, the 8 centimeters. So where does the 8 go in my second fraction? Well, because it's centimeters, it goes on top. And I'm trying to figure out what goes on the bottom. So now I cross multiply. X times 1 is just going to be 1x, or just x. And then 2 times 8 is 16. So x equals 16 yards. Now again, this is not my answer. It's just what I'm going to use to help me find area. Because to find area, I have to multiply my length right here times my width right here. So area equals the length of 32 yards times the width of 16 yards. And 32 times 16, if I put that into my calculator, I get 512 yards squared. So that is the area of the deck in that backyard. That is the end of our little mini lesson on scale drawings. Y'all have a good day.